right, so here is a bit of an explanation about the formulas in Unit 1. There aren't that many, so I'm going to just go over kind of the concepts. All right, so here we have finding the distance between 2 points. So if you're supposed to find the distance, this is how you would approach it. So if you have 2 points, here we have 1, 7 and 2, 4. I'm first going to draw a graph. So I'll draw my X and Y axis. Sorry, the puppy's making some noise upstairs. Hopefully that's not too distracting. All right, so I'm gonna go ahead and graph these. So we have 1, 7. And then we'll say 2 4s, maybe like right here. All right, we'll draw my line there. Okay, so the next thing I'm gonna do is create my slope triangle. So I'm gonna go straight down from the top point in my Y direction and then straight across my X direction. So following the X and Y axis, you create a right triangle, which means we can use Pythagorean theorem. So the first thing we're going to do when we're using Pythagorean theorem is you want to ask yourself, well, let's find my distance in the X direction and let's find my distance in the Y direction. So my X direction, we'll look across the bottom here. I'm going from there to there. Let's see, I'm going from 1 to 2. So notice my X point up here was 1 and my X point down here was 2. So between those two values, I'm moving 1 space. So let's do the same in the Y direction. So in the Y direction, I'm going from 7 to 4. So between 7 and 4, there's 3 spaces. So now to use the Pythagorean theorem, I'm going to do 3 squared plus 1 squared is equal to that distance I'm trying to find, which is the hypotenuse of my triangle here. So that distance squared. So 3 squared is 9 plus 1 squared is 1. So then we have 10 is equal to d squared. So we've got the square root of 10 is equal to d, and that's your distance. So there is a formula you can just plug your points into, but this is how the formula works. This is why we have that formula. It's just using the Pythagorean theorem. So visually, I think this is a bit more easier to understand. So once you've mastered this way of doing it, then you can go back and try using the formula. But this is how I would like you to approach the problem first. All right, so next let's talk about segment addition. Essentially, if you have a segment split into 2 smaller pieces, adding them together should give you the full piece. So here we have AB plus BC should be equal to AC. So notice I just took that smaller one plus the second smaller one, and then that should give me the total big one. And hopefully visually that makes sense. So whatever values you're given for those pieces, whether it's an expression or just a number, you can create equations with that. All right, so next, if we're talking about bisecting a segment, sometimes you might be asked to find the midpoint. So if we're asked to find the midpoint between 4, 2 and 6, -4, that means I want whatever point splits those exactly in half. I want to bisect this line and split it exactly in half. So let's first graph these on a graph. There we go. All right, so if we have 4, 2, we'll say that's about right there. And then 6, -4. All right, so let's draw our line. So now if I want to find the midpoint, I need to find the spot exactly in the middle of that diagonal line I just drew, which is not easy just to eyeball. And we never want to eyeball something in math because we want it to be exact. So let's start by drawing our slope triangle. So I'll go down in the Y. Oops, I went a little too far. Go down in the Y. And across in the X. Okay, so now I have a right triangle. So now let's find, the dimensions of this triangle. What is my slope? So in the X direction, I'm going from 4 to 6. So between 4 and 6, that's 2 spots. And now in the Y direction, I'm going from 2 to -4. So my total distance between 2 and -4 is going to be 6. So my slope triangle would be, I went down 6 and to the right 2. So now if I want to go half as far, I'm only going to go down 3 and to the right 1. So I'm taking half of my slope triangle. So I'm going down 3, and I'm only going to go over 1. So this is my midpoint, and I just need to figure out, well, what are the coordinates of that point? All right, well, let's first look at my x. So in my x, I went from, I'm going to look at this top point here. So in the x, I started with 4, and I moved to the right 1. So 4 plus 1 would give me 5. And now in my y, I started at 2, and I went down 3. So 2 minus 3 is going to be -1. So this would be my midpoint. All right. I do also want to mention, when you're bisecting segments, if you're given a straight line like this, if it asks you to bisect the segment, it just means split it exactly in half. Or if it tells you that point B bisects segment AC, then you could set those two halves equal to each other. So sometimes you'll need to do that for different problems. All right, we can also bisect angles. So it's called an angle bisector, and it means the same thing. We're splitting the angle exactly in half. So the purple angle here plus the green angle is going to be equal to this full thing. So it's equal to the blue part. So if you add those two smaller pieces together, you'll get the full thing. Same concept as we talked about before, except now we're going to be using degrees and measures. So now the angle bisector, like I said, splits it exactly in half. So you would be able to set this degree, or the measure of that part of the angle, equal to this angle. And we would know that those would have to be congruent because it's bisected, and that no matter what, if it says it's bisected, it has to be exactly in half. All right, so we can also have some angles looking like this, where it gives you, like, this might be X degrees, this might be 47 degrees, and the full thing might be like 70. Well, then we could set up our equation as x plus 47 is equal to 70. So the two smaller portions have to sum up to the larger portion. All right, next we have vertical angles. So let's see. So here the red, those are vertical angles because they're directly across from each other. And then the purple would be vertical angles because those are directly across from each other. So vertical angles, they kind of make a V with each other. I don't know if that helps, having it called vertical. But so vertical angles, they are always congruent. So those two purple angles are going to be congruent no matter what. The two red angles are congruent no matter what. And I like to, visually, if you want to see this, take two pencils or two pens or whatever, make an X and just kind of move them around a bit. Change the angles, and you'll notice that the top and the bottom, they change at the same amount. And then the two angles on the sides, they will be changing at the same amount as well. All right, next we have a linear pair. So a linear pair would be angles that create a straight line. And so a straight line has 180 degrees. So in total, these two smaller angles together should equal 180 degrees. Next, we have supplementary and complementary. So supplementary would be two angles that sum to 180. Now the difference between supplementary angles and a linear pair, a linear pair, they have to be right next to each other, where supplementary, they could be, on totally opposite sides of your diagram. So as long as you combine them, if you were to combine them together, you would create a straight line. You would get that 180 degrees. They don't have to be touching to begin with. All right, so then for complementary, we have two angles that sum to 90 degrees. So the difference there is that this complementary means if you were to combine them together, you would get a right angle, and the supplementary is if you were to combine them together, you would get a straight line. But remember, for either of these, supplementary or complementary, they don't have to be touching each other in order for you to make that claim. All right, so I think that's all I've got. Let me know if you still need some clarification.